Hi, this is Mrs. Slater, and before we get started with the lesson, I just want to go ahead and write down the formulas you need to know. So go ahead and push pause and write these down. Okay, so let's look at goal number 1. We have 2 goals today. Our first one is finding the general term, so go ahead and push pause and write down the steps that are here. Okay, so let's start our first example. It is 1, 3, 5, 7, and 9. So if you look at our first step, it is to determine if the sequence is geometric, arithmetic, or neither. And you may see already that it is arithmetic because the common difference is 2, because every step it is adding 2 every single time. So if we notice it's arithmetic, we're going to use a sub n equals a1 plus n minus 1 over d, the nth term. First term is 1. The n we do not know, so we're going to leave those open, but the common difference we do know. And after distributive property, you get this. And after simplifying, you get this. So that we have just found is our general term. So it's called the general term because now we can find any term in a sequence by just plugging a value in for n. Okay, so let's try another one. The example is 3, 9, 27, 81, and so on. So as you can see, or maybe not, if you look at each jump, it's going to multiply by 3. So it is a geometric series, and the common ratio is 3. So we are going to use the geometric nth term formula, which is a sub n, and then a1 times r to the n minus 1. So a1, or a sub 1 is 3. R we do not know. Yes we do. We know it's 3. And then you have n minus 1. We do not know what n is. Okay, but we can simplify this a little bit. This is actually 3 to the first power. And as we know with anything with the same base, we can add those exponents together for a simplified answer of 3 to the n. So this right here is our general term for this geometric sequence. General term. Okay, let's try another one. Two-thirds, 3/4, 4/5, 5/6, and so on. The trickier ones like this, I like to use the test for arithmetic sequence. So we can take 3/4 and subtract 2/3. And if I do a common denominator, that would be 12 and 12. So that would give me 8 and 9. And so I get 1/12. Okay, if I subtract 4/5 and 3/4, and then do the common denominator, that's 20 and 15. And that would be 16, and I get 1/20. So that means it's not arithmetic. Okay, so then the test for geometric is division. So we have 3/4 divided by 2/3, and we know fractions have to multiply by the reciprocal, and you get 9/8. And then the third one divided by the second one would be multiplied by the reciprocal, and you get 16 over 15. So since those do not match, it's not geometric. So since it is neither, we have to look beyond what it is given. So we don't have a specific one to use, but if you notice, there is a pattern in the numerators, which is arithmetic. It's going up by 1. So for the top, we're going to use the arithmetic sequence, which is a to the n and a1 plus n minus 1 times d. And if I plug in a 2, and then if I plug in the common difference of 1, I get 2 plus n minus 1, and our nth term would be n plus 1. Okay, so that takes care of the numerators. Now the denominators on the bottom, we're also going to see that it's hopping up by 1 or jumping by 1. So we're going to use the arithmetic sequence for that as well. So a1 plus n minus 1 times d, And then the first term is 3, n minus 1 times 1, and 3 plus n minus 1 for a final denominator answer of n plus 2. Okay, so by combining the two of them, we'll be able to find the general term for this sequence. The top we found to be n plus 1. The bottom we found to be n plus 2. So that is going to be our final answer for the general term. Okay, now let's take a look at another type of problem. We have the square root of 3, the square root of 5, the square root of 7, the square root of 9, and so on. Okay, if you do the test, because this is kind of a different one than we're used to, if you do the test for arithmetic, square root of 5 minus square root of 3, and then the square root of 7 minus square root of 5. If you plug those in your calculator, you end up with like 0.504, and this one's 0.409, so it can't be arithmetic. And then the test for geometric would be square root of 5 divided by square root of 3 and square root of 7 divided by square root of 5. And for both of these, you get 1.29 and you get 1.18. So it cannot be a geometric. So now we just have to think outside the box because we have neither. So if you notice, there is a 3, 5, 7 underneath the radicals, and that is definitely an arithmetic sequence. So we're going to go ahead and use the arithmetic sequence formula, where d is going to equal to 2. So a sub n equals a1 plus n minus 1 times d. And if you plug in the first term, you have 3, and then n minus 1, common difference of 2. 3, little distributive property, gives us this equation, and then 2n plus 1 would be the general term. Now, for the whole thing, though, all that square roots, how we can finish this up is by taking what we just found, 2n plus 1, and put it underneath the radical sign. And that will finish up that one. Okay, so let's go on to our next goal, which is we are going to write sigma notation for each sum. And so we're going to need the general term because the first step is to set it up with a sigma notation and find the general term next. So go ahead and push pause, and we will get started. Push pause, finish them out, and then we'll get started. First example, 1, 4, 9, 16, 25, and so on. Oops, nope, no, so on. Okay, so it's a finite sequence, and first step, we're going to go ahead and set up the sigma notation. And in that sigma notation, we need to have the beginning and the end. Well, as you can see here, we have the first term, we have the second term given, the third, the fourth, and the fifth, and it stops there. So n is going to equal 1, and it's going to stop at the fifth term. So that takes care of step 1. Step 2 is to find the general term. Now, it's not adding by 3 every single time, and it's not multiplying by 4 every time, so it can't be either geometric or arithmetic, so we can't use one of those formulas. And then we got to think beyond arithmetic and geometric, which means, where have you seen these before? 4, 9, 16, 25, these are all perfect squares. And anytime you have a perfect squared, it is a number squared. So a number n squared is going to be our general term. Okay, so a sub n equals n squared, because if I plug in a 1, I get 1. If I plug in a 2, I get 4. If I plug in a 3, I get 9, and so on. So then the last part of sigma notation is going to go in front, to the right of the sigma notation. Okay, let's go on to the next one. Okay, and on this one, I am giving 2, 4, 6, 8, 10, and 12. First step, get your sigma notation lined up, and go ahead and look at how many we are given. 2, 3, 4, 5, and we are given 6 terms this time. So we're starting with 1, and we're ending with 6. Okay, so to find the general term, you can see that they all are adding by 2. So we have an arithmetic with d equaling 2. So that means we're going to use a to the n, or a sub n, and then a1 n minus 1 times d. We know the first term is 2, and we know the common difference is 2. So we add those in there. 2 plus 2n minus 2, and then for a general term of a sub n. So that general term is going to be located right here in front, and I keep saying in front, to the right of the sigma notation. Okay, and then the last one for this video is going to be 2, negative 3, 4, negative 5, and that does have ... to the back of it. Okay, so if you check for the test for arithmetic, if I subtract negative 3 minus 2, I get negative 5, and 4 minus a negative 3, I get 7. So it cannot be arithmetic. The test for geometric is negative 3 over 2, and that's just negative 3 over 2, and then 4 over negative 3. So neither one of those match, so that can't be geometric. So what can you see? Well, if you notice, there's a 2, 3, 4, 5, which is arithmetic, with a common difference of 1. So we at least can find what that's all about. A sub n equals A1 plus n minus 1 times d. First term is 2, and then it goes up by 1. And then we get 2 plus n minus 1, and what do we get? N plus 1. Okay, so that takes care of 2, 3, 4, 5. And then if you look at the rest, we have 1, negative 1, 1, negative 1. You can just see this alternating pattern happening with the negatives. So if you look at that, this is a geometric sequence with a common ratio of negative 1. So if you divide the second and the first, you would get negative 1. So the formula for that is going to be A1 equals, I did it again. A sub 1 equals A1 times r to the n minus 1. First term is 1, common ratio is negative 1 to the n minus 1, and anything times 1 is itself, so negative 1, and then to the n minus 1. Okay, so the sigma notation, where it starts is A1, goes to A2, A3, A4, and then just keeps on going. So then keeping on going means they're going to have an infinity sign on the top, and n equals 1 on the bottom. General form is going to, or general term, we have n plus 1. And then we also have, so n plus 1, oops, okay, start over here. N plus 1, and then also negative 1 to the n minus 1. And I don't like the way that looks, so we're going to put n plus 1. Sorry about this. N plus 1. Done. Okay, that is your general term, or in sigma notation. You got your general term in sigma notation. And that concludes the lesson for tonight. So thanks for listening.